we are going to be doing just the first page today. All right, so we're splitting up 7-1 into 2 days. So all we're doing today is the simplifying the square roots. All right, so we're simplifying the square roots.
I'm not good at square roots.
Well, we're going to get good at them.
I'm supposed to be.
Yeah.
Okay, because I'm like, I'm going to get this.
All right. First question says, what is a radical? So a radical is a square root symbol. It is also a cube root or a fourth root or a fifth root. So anything with this symbol right here is called a radical number. Yep. Which is also why if you look at the poster over here, the radical function is the square root and the cube root functions. All right, so roots and radicals are the same thing. Specifically today, we're going to be working with square roots of numbers, and we're going to be simplifying them. So to simplify, the square root of 25 is what? 5. Because 5 times 5 is 25. All right, square root of 49, 7. And the square root of 64? 8. Good. So this one is 7.
Square roots are like half.
Not really halves. It's like what multiplies times itself. 7 times 7 is 49. 8 times 8 is 64. All right, ignore this box for right now. Let's review the perfect squares. I know we did this when we did difference of squares, but now we're talking about square roots, so we're going to do it again. All right, so perfect squares. What is 1 squared? 2 squared. 3 squared? 9. 4 squared? 5 squared? 6 squared? 7 squared? 8 squared? 9 squared? 10 squared? 11 squared? 12 squared? Oops. 13 squared? 14 squared?
I don't know. You just told us to go.
Yeah, 196.
196.
I don't think you'll normally go up to 13 or 14, but that's what they are. Yeah, the numbers just switch, ironically. So, all right.
And then the other one is 196.
And then I think 15 squared is what, 225 or something like that. Oh. All right, now this box right here. This box is just kind of explaining the notation your square roots are going to be in. So you're going to have a number on the outside here. This is called your coefficient. It's like you would normally treat regular coefficients. And then you have your root symbol, specifically the square root. And then the guy on the inside is called your radicand. It's the guy inside the house. All right, so those are kind of all the parts of the square root. All right, one other thing we want to talk about is the I. Any number with an I is called an imaginary number. All right, so an imaginary number is a number with an I. All right. And the term imaginary number is just how you would classify that number. I don't know if you remember back when, way back when you classified numbers, like you had real numbers and whole numbers and integers and rationals and radicals and I can't remember the rest of them. Yeah, it's okay. You don't really need to know it, but imaginary number is just another classification of numbers. All right, so that's all that is. It's a number with an I. And what we're going to talk about today is when there is a negative inside the square root. That means I. So they're the same thing. So negative inside the square root means an I. And the reason why it's imaginary is because if you try in the calculator to type in the square root of negative whatever, it's not going to work. It's going to say non-real number because there is no such thing as a square root of a negative number. Also, if you look at the square root graph, if you notice, the graph doesn't go to the negative side, right? It stays on the positive. See what I'm saying? The arrow to the right? It only stays on the positive because it only can use positive numbers. So that's why that graph is the one graph that stops because you can't have the negative numbers. The radical one, the square root one, the stops and then arrow. All right, so anyways. Part C is like the main stuff today. All right, so this is like the problems you're going to be doing. Angie, put your phone away.
Yeah.
All right, so simplifying. No decimals. The good news about this is that I do not think the Nspires can do this. All right, so you can use your calculator to help you with the multiples if you need to. All right, because if you typed in the square root of 50 in your calculator, all it's going to do is spit out a decimal. All right, I do not think, at least I don't know how, the calculators can simplify these guys. So you have to do it by hand.
How do you do it?
I'm gonna show you.
Okay, what color is that?
Navy blue.
I got you, bro. Thanks.
Yep. All right. Oh my gosh, did you hear it? Yep. All right. Anyways, so I'm gonna take the number inside. I'm gonna write it out here, and we're gonna do our little factor tree with 50. Yeah, I think you've done it before. Even if you and your buddy do the factor tree differently, you will still end up with the same answer.
So it's gonna be like 5 and 10.
5
Yeah.
and 2. It's 2 5s and 1 2.
Yeah. So I'm going to use 5 and 10. If someone else used 2 and 25, you'll still end up with the same thing. All right, so 5 and 10, and then break down 10. 5 and 2.
So it'd be 2 outside and 5 inside, right?
No, backwards. Okay, so wait, just hold on.
Sorry.
It's okay. All right, so you break it down as far as you can go. Now, I am only concerned with the end of the tree. All right, I'm only concerned with the end of the tree. So I don't care about this number. I don't care about this number because I broke them down. All right, so I only am concerned about the stuff at the end. So if it helps you, after you break a number down, cross it out because you don't really need it anymore.
And what about the 5?
This is what I need.
Why don't you just circle? Say we didn't catch
Because you
it.
did
That's
break
fine.
down.
Blue chili.
You're making it complicated.
All right, so I'm looking for, oh my gosh, I did it again. I'm looking for pairs. What do I have a pair of?
5.
5. So I have a pair of 5s.
Oh wait, so it's gonna be that and then.
Yeah, hold on. Shh. I know you've already done it, but just hold on. Okay. I have a pair of 5s because there's a pair. They're going on a date and they are going outside of the house. So 5s are going on a date. The 2 does not have a date. It is all by itself. So it's single. It stays at home in the house. That's how I remember it. I know you did this before, probably. And so if you have your notation a different way, like Faith was saying that she uses circles or whatever, that's fine. But that's just the way I remember. So pairs go on a date outside. Leftovers stay at home inside the house.
All
Leftovers.
The 2 is leftover. It doesn't have a date.
You said date, so I was thinking people, and then you said leftovers. You're confusing species.
You do 25 and 2.
Yeah, sure. All right. So if you did 2 and 25, we're just cracking a lot this period. And then 25 breaks down to 5 and 5.
Get one.
And so then pair of 5s, 2 is still left over.
Okay.
Is this I?
Me too.
because
This
there
So this
are.
is dumb, but you wouldn't break down 2 into 1 and 2.
No, don't use 1. Yeah.
We're not going to know.
All right, so shh, hold on. This is taking too long because there's too many side conversations. So if you get it, great. Quit talking though. Shh. It does not matter if the 5s are next to each other. If they're at the end of the tree, you can still pair them up. So just because my loop here is a lot bigger than this one, it doesn't matter. All right, these are still at the end of the tree, so I can still pair them up even though they're not right next to each other. It doesn't matter. All right, so you're just looking for pairs. All right, let's do another one.
Yes. Are we doing 4 or 5?
We're going to do 4.
Okay.
All right, so on number 4, once again, if you got it, great. Quit talking. So everybody else that's still kind of understanding it can figure it out. The 3 on the outside is just going to stay there. You don't do anything with the 3 because we're just trying to break down the root. So I'm going to take 200 and I'm going to break it down. So tell me, 2 numbers that multiply to give you 200.
20.
All right, 20 and 10. All right, and then we're going to break it down farther. Remember, since I broke down 200, I don't need it anymore. 20, does it break down?
Yep.
All right, 10 and 2. I broke down 20, I don't need it anymore. 10, does it break down? To what? 2 and 5. All right, I broke down 10, I don't need it anymore. This 10 can also break down.
Stop making fun.
2 and 5. It's okay. I just need
That's why
water.
you'll never be able to babysit Jacob.
When you're not my student anymore, you can babysit him. I think there's like a thing against it.
There's a
Yeah,
rule.
I'm pretty sure
You go
I
in the
will.
bathroom, you look up.
All right, so I've broken everything down as far as it can go. What do you have a pair of? Pair of fives and a pair of twos. And then do you have anything left over?
Yeah, you guys.
Would you call triplets a pair? I don't think so.
You have a 2 left over. All right, so 3 is already out here on a date. What else is going on a date?
5 and 2.
The 5 and the 2. And then what is left over? The other 2. Now, the numbers on the outside, you're going to multiply them. So if you have multiple pairs or multiple leftovers, you multiply. So 3 times 5 times 2,
30.
30, square root of 2.
So, is there an instance where there could be like another lone pair? Like somewhere like in there was also a 3 that was like by itself.
You mean like 2 leftovers? Like, yeah. So you would just multiply the 2 and the 3, and so inside would be 6.
Okay, thank you.
Yep.
I'm so confused.
Okay.
We're just giving a random number.
And
All right, number 5. All right, what do you notice about number 5?
it's negative.
It's imaginary.
It's got a negative, so it's imaginary. So I'm going to take the negative out. I'm going to put an I. All right, the negative, I take it out. I put an I.
We love a good.
What do you do with the negative?
You take it out and you replace it with an I.
But wouldn't you just put -1 as the same thing?
Hmm?
You just put the -1 as the same thing.
No, because then you're making the square root negative, but it's not negative, it's imaginary. All right, so you take the negative out, you put an I. Now we're going to break down 27.
9 and 3.
9 and 3,
Would be 3 threes.
3 and 3.
Uh-oh.
All right, so we're looking for pairs. So what do I have a pair of? 3s with what left over?
3.
A 3.
Okay, well, what about that?
So it'd be I3.
Normally you see the I second, so 3I. But if you wrote it that way, I'd be okay.
3I3.
3I, square root of 3.
That's so cool, guys.
So you just make the negative of positive.
But this time the I is negative. Now I'm lost.
So
I
crazy.
know, but like,
All right, jump down to number 10.
Wait, no, can you do 6?
I'm sorry.
I'll jump up there. I just want to talk about number 10 real fast. I'll have you all try 6.
Oh, we still have practices to do.
All right. Number 10. I'm going to take 72. I'm going to break it down to 2 and 36. There's a reason why I want to do it this way.
I remember you was conflicted.
All right, now 36 breaks down to 6 and 6, right? All right, wait, hold on. Before I break this down any farther, what do you notice?
It's a pair.
It's a pair. So if, hold on, because this is important. It will save you some time. If you come across a pair, you don't have to break it down. All right, we can circle this pair right here because I am just looking for pairs. It doesn't matter that it's not broken down all the way.
What if you did 12 and 2? I mean 3.
You'll end up with the same answer.
Okay. 30 and
Okay, so 36 breaks down to 6 and 6. I'm going to circle that pair. And you just have to make sure everything else is broken down. Since 2 is 2 is as far as it can go, then you're done. Pair goes on the outside. So the 6 is going on the outside with the 5. And the 2 is going on the inside. So your final answer is 30 square root of 2. All right, now let me show you how you would get the same answer if you finished it out. All right,
Wait, so are 4 and 10 the same answer? How did that work?
hold on. Let me finish this part. All right, so if I were to break this down farther, 6 breaks down to 3 and 2, 3 and 2. You can't break that down any farther, so I have a pair of 3s here, and I have a pair of 2s here.
multiply it anyway.
And so you're going to multiply it anyways. So that's why you don't have to break it down all the way if you don't want to. Because you'd have a pair of 3s you'd pull out, a pair of 2s you pulled out. You're going to end up multiplying. Does that make sense?
I feel like I'm going to break it down anyway because I'm going to break it.
Yeah, and if you break it down anyway, it really doesn't matter.
Really be on test though.
All right, take a second, try number 6 on your own. Number 6, yep. 5 and 25 give you 125, by the way. Try number 6. And that'll be my last one, if y'all are good with that. No, we're going to do the back tomorrow. Bless you.
Miss Dahl?
6.
5 and 25.
25 and 5. Yeah, so I got 5, 5. 5.
Right?
20.
20 How do you get? Wow.
We're doing it.
25 and 5.
We're doing it.
Oh, that?
If there are 2 pairs of the same number, you multiply them.
I think it's 20.
You have the I, right? So it'd be 25.
Yep. All right, shh. Focus up here. Up here, up here, up here, up here. Okay, Lily, what's the first thing I'm going to do? Yeah. Not yet. Before that. Take out the what? The negative and turn it into a what? An I, yes. So I got to take the negative out. I'm going to turn it into an I. And then I'm going to break down 125. So, Daniela, 125, what are 2 numbers? 5 and 25. And then, Haley, what are 2 numbers for 25? 5 and 5. Kiadra, what's my pair? Pair of 5s. And then Jasmine, what's left over? A 5, good. And then Angie, how would I write this?
Well, you multiply the pair of 5 by the 4i,
Very good. So we're going to put the 5 on the outside and multiply.
and then you're gonna put the lone one inside. So
Good.
you'd multiply it and you'd get 20i
Mm-hmm.
square root of 5.
Very good.
Thank you.
Oh, we were still recording.